Welcome to Easy Physics classes. Question number 1.10. An electric dipole with dipole moment 4 into 10 raised to minus 9 coulomb meter is aligned at 30 degree with the direction of a uniform electric field of magnitude 5 into 10 raised to 4 Newton coulomb raised to minus 1. Calculate the magnitude of the torque acting on the dipole.
To solve this problem, we should know what is electric dipole and electric dipole moment vector P. Electric dipole is a pair of equal and opposite charges separated by very small distance. That is, here minus q and plus q are equal charges, but they are opposite in nature, that is having opposite signs, and they are separated by a distance 2a. This 2a should be very small. Then this pair of charges can be considered to be an electric dipole. So, electric dipole is a pair of charges. It must be having equal charge but opposite signs separated by very small distance. Now, the strength of electric dipole is represented by the term electric dipole moment vector P. Electric dipole moment is treated as a vector, and the direction of electric dipole moment is taken from negative charge to positive charge, that is from minus to plus. I have written p cap here, that p cap represents direction of electric dipole moment vector, that is from negative to positive. Magnitude of electric dipole moment, that is equal to magnitude of either of the two charges, that is q into separation between the two charges, that is this 2a, that is magnitude of dipole moment will be q into 2a. These all are defined. Now, in this problem they have asked us to find out what is the torque acting on a dipole. So, before that we will derive the equation for torque acting on a dipole placed in uniform electric field. Imagine that this is the dipole which is placed in uniform electric field. I have drawn the electric field using dotted lines, equally spaced dotted lines like this. The field lines, electric field is having a direction towards the right side. So, electric field is represented by the letter vector E, and theta is the angle between the direction of dipole moment and vector E. Dipole moment is a vector quantity. The direction of dipole moment is from negative to positive charge. So, this direction. And there is an angle theta between vector E and vector P. Now, since these two charges are placed in an electric field, they will experience force given by charge into electric field intensity, that is QE. This is a positive charge, so it will experience force in the direction of electric field, and this is negative charge, so it will experience force opposite to the direction of electric field. Since both the charges having same magnitude, the magnitude of force will be also same, because it is a uniform electric field and both charges are having same magnitude. So, electric field is constant and charges are same. So, the magnitude of force experienced by both these charges will be same, that is QE. Both will be QE, but direction of forces are different line of action also. So, they will form a couple. Due to this couple, the dipole will rotate. Due to this couple, the dipole will rotate like this. So, a torque will be acting on the dipole. Torque is nothing but rotational effect of force, which we have learned in 11th class. And the torque acting on the dipole can be found out by using this formula. That is torque tau equal to, since it is a couple, torque tau equal to magnitude of either of the two forces, that is QE, into perpendicular distance between the directions of the two forces. This force is acting along this line, and this force, this QE, is acting along this line. So, the perpendicular distance between these two lines will be this one. This will be the perpendicular distance between these two directions. The perpendicular distance will be this one. So, from this triangle I am going to find out what is sin theta. Sin theta equal to perpendicular distance divided by 2a, and from there we get perpendicular distance equal to 2a sin theta. So, I am going to substitute tau equal to magnitude of either of the two forces, that is QE into 2a sin theta, but Q into 2a is magnitude of the dipole moment P. So Q into 2a is written as P, the dipole moment, into E sin theta. This is magnitude of torque acting on the dipole. Now, since torque is a vector quantity, we can write in vector form, that is AB sin theta form. So we can write A cross B in vector form, that is tau equal to vector P cross vector E, and the direction of torque will be perpendicular to the plane containing P and E, which we can find out by using right hand thumb rule. Imagine that this is the dipole. So here there is a force acting in this direction, here also there is a force acting in this direction. So what happens is that the dipole will rotate like this, a force in this direction and a force in that direction. So it will rotate. Dipole moment is represented by the letter P. It is a vector quantity, so vector P. Direction of dipole moment is taken from negative to positive charge, that is represented by pk. Now magnitude of dipole moment vector P equal to magnitude of either of the two charges into distance between the two charges, that is magnitude of either of the two charges means Q into distance between these two is 2a. So Q into 2a. SI unit of dipole moment is coulomb meter. Now coming on to question number 1.10. We know the formula to find out magnitude of torque equal to PE sin theta, where P is the dipole moment, E is the electric field intensity, and theta is the angle between direction of dipole moment and direction of electric field intensity. All these three are given. P is having a value 4 into 10 raised to minus 9, E is having a value 5 into 10 raised to 4, and theta is 30 degree. So we get 20 to 10 raised to minus 5 into sin 30 is half, so it is equal to 10 raised to minus 4 Newton meter.
Question number 1.9. A system has two charges QA equal to 2.5 into 10 raised to minus 7 coulomb and QB equal to minus 2.5 into 10 raised to minus 7 coulomb, located at points A 0 0 minus 15 centimeter and B 0 0 plus 15 centimeter respectively. What are the total charge and electric dipole moment of the system?
So here in this question we are having two charges QA and QB. QA is 2.5 into 10 to the power minus 7 coulomb. QB is minus 2.5 into 10 raised to minus 7 coulomb. QA is placed at point A and QB is placed at point B, whose coordinates are 0 0 minus 15 centimeter and 0 0 plus 15 centimeter respectively. That is, they are placed along the z axis. QA is placed along negative z axis and QB is placed on positive z axis. The distance between these two charges will be, since this is minus 15 centimeter and this is plus 15 centimeter, the distance between these two charges will be 30 centimeter. So we have to find out what is the dipole moment of this combination. Before that, the net charge of this combination will be 0, because first charge is having plus 2.5 into 10 raised to minus 17 coulomb and second charge is having a value minus 2.5 into 10 raised to minus 7 coulomb. So the net charge will be 0. In this case, net charge will be 0 because these are two equal charge with opposite sign. So the net charge QA plus QB will be 0. Magnitude of dipole moment is magnitude of either of the two charges, that is 2.5 into 10 raised to minus 7 into distance between these two charges, that is 30 into 10 raised to minus 2. Solving, we get 0.75 into 10 raised to minus 7 coulomb meter, which is the SI unit of dipole moment. It is coulomb meter. Now direction of dipole moment is from negative charge to positive charge, that is from B to A, that is along negative z axis.
Thank you for watching. Please subscribe our channel for more updates. Since the NEET and JEE exam dates has been published, we'll be discussing questions based on NEET and JEE patterns in the coming videos. Please watch, share and subscribe.